In this lesson, we will develop and use properties of natural logarithmic functions, understand the definition of the number e, and find derivatives of functions involving the natural logarithmic functions. Let's begin. First, a review of some of our logarithmic properties that you should already be familiar with. Remember that the natural log of 1 is always equal to 0. And then there are some of the expansion rules here that we need to remember when you have the natural log of a product, that can expand into the natural log of A plus the natural log of B. When you have the natural log of a power, remember the power you would multiply by the power. That becomes n times the natural log of A. And then if you have the natural log of a quotient, then remember that becomes a difference problem, a subtraction problem. Natural log of the numerator A minus the natural log of the denominator B. These expansion rules, properties, will be very useful to us when we begin to find derivatives of the more complicated natural logarithmic functions. Alright, so just a practice with expansion. We want to use properties of logarithmic expansions to rewrite this expression, the natural log of 1/5. So the natural log of 1/5, because it's a quotient, remember it can be rewritten as the natural log of 1 minus the natural log of 5. Well, the natural log of 1, remember, is 0, so then we would have 0 minus the natural log of 5. So we end up with a final answer of the negative natural log of 5. Or we could say the opposite of the natural log of 5. The letter E, remember the letter E denotes the positive real number, such that the natural log of E is equal to 1. If you remember from Algebra 2 and trig that natural log and E are inverses of each other, so they cancel each other out, and the natural log of E will always be equal to 1. Remembering that the natural log of E is equal to 1 will be very useful to us in simplifying expressions involving the natural log of E. Once you know that the natural log of E is equal to 1, you can use logarithmic properties to evaluate natural logarithms of several other numbers. For instance, if we had the natural log of E to the nth power, we could first expand it so that we had n times the natural log of E. And since we know that the natural log of E is equal to 1, we would end up with n times 1. And remember that the natural log of E is equal to 1, so now we have natural log of E, n times the natural log of E is equal to n times 1, so we end up with just n. Alright, let's move on. Finding the derivative. This is really what we want to get to today. Up until this point, we have not found the derivative of natural log functions. The derivative of natural log functions, if you have the derivative of a natural log, the derivative of a natural log would always be equal to 1 over x. Okay? So the natural log of x is equal to 1 over x. Only thing you need to keep in mind is if you have something more than x here, you have a function, 2x, x squared, anything like that, then it's still your 1 over whatever you're taking the natural log of, so 1 over u, but then you need the derivative of u. And to simplify that, when you're finding the derivative of the natural log of u, what you need is the derivative of u over u. Okay? So if f of x were equal to the natural log of u, and you wanted to find the derivative of f of x, well, then it would be equal to the derivative of u over u. Okay. The derivative of u over u. All right, so let's look at an example. Here we want to find the derivative of the natural log of 2x. Okay, so remember the 2x, this is your u, and when we find the derivative here would be equal to the derivative of u over u. Well, the derivative of 2x would be 2, and since u is the 2x, then 2x would go on the bottom in your denominator. The 2's could cancel out, and your final answer, f derivative of x, would be equal to 1 over x. Okay? So the derivative of a natural log is the derivative of u over u. Let's look at another example. Okay? All right, keep in mind that we would use x squared plus 1. That would be our u. Remember the derivative of the natural log of u I've written this incorrectly. Let's rewrite this. If f of x is natural log of u, then the derivative of f of x would be equal to the derivative of u over u. So keep your rule in mind. So if u is equal to the x squared plus 1, the derivative of u is 2x. Well, we want the derivative of u over u, so the derivative here of our function would be equal to the derivative of u, which is 2x, over u, which is x squared plus 1. Done. All right. Here we go. Here we want to find the derivative of x times the natural log of x. Because we have a product, we're going to need to use our product rule along with our rule for our natural log. Remember with the product rule that the derivative here would be equal to the derivative of the first term in the product, which would be the x. Derivative of x would be 1. Leave the second function alone, because with the product rule, remember you add, and then you leave the first factor alone and take the derivative of the second factor, natural log of x. Derivative of natural log of x would be 1 over x. Then simplify. 1 times the natural log of x would just be natural log of x, plus, we'll multiply x times 1 over x, you would end up with x over x. X over x would simplify to 1, so we end up with the natural log of x plus 1. Okay? So although it looked a little more complicated, we can use things that we already knew how to do, the product rule, along with our new rules for natural logs, and end up with our final answer, natural log of x plus 1. Okay, let's move on. Okay. Again, you'll need to put some of the old things that we know along with the new. Here we'll need to use our chain rule. We have an inside-outside function. So to take the derivative here, we do the derivative of the outside. Okay, so it'd be 3 times the natural log of x, now raised to the second power, okay, times the derivative of the inside. Derivative of natural log of x would be 1 over x, and then simplify. So we would end up with 3 times the natural log of x squared all over x. Done. Okay. All right. Again, we have an inside-outside function. Don't make it harder than what it is. Remember to find the derivative. What we want is the derivative of u over u. We'll use the inside function, so we want the derivative of u, which would be 2x, over the inside function u, which is x squared plus 3. Done. Okay, so don't have to make these any more complicated than, they're pretty simple if you just keep in mind the derivative of a natural log is the derivative of u over u. Okay. All right. Now, we could make this really complicated trying to use our quotient rule. Don't have to do that with natural logs. We can rewrite the function using expansion rules of natural logs. Remember, if you have the natural log of a quotient, it can be rewritten as a difference problem, the natural log of x minus the natural log of x plus 1. And just like any other time when we're finding the derivative of a sum or difference, we find the derivative of each term separately. So when to find the derivative of the first term, natural log of x, remember that derivative is just equal to 1 over x minus the derivative of natural log of x plus 1. Well, here we would use the u substitution idea. We want the derivative of u over u, so the derivative of x plus 1 would be 1 over u, or the x plus 1. Okay. Now, I want to simplify this, so we need a common denominator. The common denominator here would be x times x plus 1. So we need to multiply the first term times x plus 1. The numerator and the denominator we would multiply by x plus 1 to get that common denominator, so that make the numerator here x plus 1. And the second term we need to multiply numerator and denominator by x, so we would end up with minus x. Cancel out the like terms, and we would end up with 1 over x times x plus 1. You could leave it like this in its factored form. Some of you may want to go ahead and multiply that denominator, put 1 over x squared plus x. Either answer there would be acceptable. And that's it. You may begin your homework, and I will see you tomorrow. Here's a reminder of what your homework is. Alright, the homework for this assignment is number 5.1a, page 329, numbers 3 through 9, 19 through 35, 41 through 51. You only need to do the odd, and you should have a total of 19 problems when you're done. See you tomorrow.